2.1, organizing qualitative data. So first of all, we have these learning objectives, so let's get right into them. But before we get into those, when data is collected from a survey or design experience, they must be organized into a manageable form. Okay? Any data that's not organized, we call that raw data. That is just the stuff that has been inputted there. We've not done anything with it. We've just collected that data, not done anything. That is our raw data. Okay? All right, so objective one, let's organize qualitative data in tables. Now, frequency distribution is one of our main ways of doing this, and that lists each category and the number of occurrences for each category of data. So here, for instance, we have our raw data, and so we're looking at a physical therapist to determine types of rehabilitation. So samples 30 patients and writes down their type of rehabilitation. So back, wrist, elbow, hip, knee, shoulder, so forth. With that, and looks at all of those pieces and then construct a frequency table based on that. So the frequency table would look like this. We would take the body part and put it in our first column, and then you can put your tally marks, but we would do that in the process of finding how many we needed. You wouldn't usually put this into a report, but you could do that if you needed to, or just go to the side kind of on scratch paper and put your tally marks. And then we add all those up to look at our frequency. Okay, and so that frequency would go into our last column there with those. Okay, and so if we go back and look, we would see that we had 12 back issues, 2 wrist, 1 elbow, and so forth, all the way down through those. Okay, and so that gives us a distribution, a frequency distribution of these items. All right, now there's just a caution here. Table 2 is qualitative. The frequency represents the count in each category. So don't think that this is a quantitative. In this case, it is still qualitative because we're talking about we have a back issue, a neck issue, a back issue, so forth. Okay. Now the relative frequency, this is a proportion or a percentage of observations within a category. And we get that by dividing the frequency by the sum of all the frequencies, by the total amount is what that means there. Okay? And so we could then create a relative frequency distribution for each category. Okay? So if we take the stuff from that previous table and we add all of the values in table 2 there, we would find that there are 30. And we said that at the beginning, that she sampled 30 people with those. Okay? And so we can see that if we were to look at back specific list, the first one on our list, had a frequency of 12. So 12 divided by 30 is 0.4. So the relative frequency is 0.4 for that. Or it would be 40% if we change that to a percentage. Most of the time in your homework, they're just going to want the decimals. And then we would continue that down all the way through to the bottom for each one of those. Okay, so we'd have 1 out of 12, out of 30, sorry, 2 out of 30, 1 out of 30, and so forth, and get all of those things on those pieces. Now, a couple of things should be happening when you do these. Your relative frequency should add up to 1. So notice down at the bottom there, it has a 1 on those because it's a proportion with those. Okay, so just kind of marking there, notice that right down there, that's a 1 with those. And then over here is their total, so we have both of those items. Okay. All right, objective 2, construct bar graphs. So a bar graph is constructed by labeling each category of data either on a horizontal or vertical axis, and then the frequency or relative frequency based on whichever one we want to use on the other axis. And then rectangles are drawn for each category. The height of the rectangle represents the frequency or the relative frequency. Okay? All right, so here is going back to our table. So we said that our back had 12, our wrist had 2, our elbow had 1. So notice there that in our first table that we have here just the regular frequency. And then on our second table here, we have relative frequency for those. So we can do it either way. Now those tables are going to look very, very similar to each other. The big difference on those is going to be these numbers here, okay? Whereas on the frequency, those are going to typically be whole numbers. Relative frequency is always going to be a decimal less than 1 with those pieces, okay? So we notice all the shaping is the same. All right. Now graphs that start with a scale of some other value than 0 or have unequal bar widths, these can misrepresent the data, so you want to be very careful on that, okay? We want things to start at 0 if possible, or at least things to be noted that we're not starting at 0 on those, okay? And then we want to keep our widths the same if possible. Don't do a bunch of different colors or three-dimensional just because they detract the eye from what is really trying to be said there. Okay. All right, so here's just more of the same. They use the spreadsheet to do all this from Excel. You can do that. You can do it in the calculator, but these are typically not very difficult to do. With those, we're not going to worry about going through them. We can see those. There's going to be a lot of multiple choice in your homework, selecting which one is which on those pieces. So hopefully you can see those things. If you have questions there, again, as always, make sure you ask. All right, the next part is a Pareto chart. It's a bar graph, again, but it just puts things in decreasing order of the frequency. So it will always go down in size. So notice here that our first one is the tallest bar up here, and then we work our way down on those. So it just means that we put it in order there for them. So if it asks for a Pareto chart, we just want it in descending order when we're looking at those. All right, side-by-side bar graphs. This allows us to look at two sets of information at the same time. So for instance, if we wanted to look at last year and this year, we could do that. Or men versus women, we could do that, okay, for those. So here's one of those types. So we came up with the data here from 1990 and 2017 dealing with education. And so we draw our side-by-side here. We can see it. Now they decided to go with the relative frequency instead of normal frequency, but we can see which one of those. So in blue is 1990, in green is 2017, and how those changed over the years and different things like that. Okay, so we can see all of those pieces on those and compare things. Now we don't want to do too many things, but doing 2 items is not bad. Okay, so then we can make conclusions on any of those pieces. All right. Now we can also do them horizontally if we would like to. There's nothing special there on those, but it just kind of changes how we read it. It may make it a little bit easier in this case. Notice when we're reading our degrees and things on the side over here, it just makes it a little bit easier to read those items, but doesn't have to be that way. So whichever way we would like, you just want to make sure that your graph is clear to the reader and you're able to convey the message that you want to without confusing them. All right, last objective, construct pie charts. So a pie chart is a circle divided into what we call sectors. It looks like pizza pieces or pie pieces. On those, each sector is a proportion. So these are always proportions to the frequency. So you can think of them as always relative frequency when we look at a pie chart. Okay. So again, looking at the education degrees there, we want to take them and break those things down. All right. So we look at the relative frequency, and we could create those pieces. Now again, the degree here, how they came up with all of these things, we're not going to get have to worry too much about that. It'll be multiple choice. But we are breaking up 360 degrees. That's a circle. So that's where that comes from there when you're looking at those pieces. So this 360. And then we would take the percentage. So we would multiply. That's why they're multiplying there by that number. All right. And so then we have that broken down for us. And so again, notice they're all percentages. It's not a regular frequency. It's a relative frequency every time with these. And so that's how we would create those things. So being careful when you're doing those and labeling those things out. Okay? All right, so that's the things that you're going to need there for 2.1.